Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to do a little bit something different. I recently bought a book and it came in the mail yesterday, so it came early actually. It was supposed to be delivered today, but it actually came in early. It's called Basic Partial Differential Equations by David Bleecker and George Sesoras. So I don't know if I pronounced those names right, but hopefully I was able to at least get them close to correct. Anyway, so I thought why not just pick up this book, and when I read the preface, according to this book, at least according to the preface, I guess I'll just read where it read in the preface. It basically says, having taught from the material in this book for 15 years with much feedback from students, we found that the book serves as a very readable introduction to the subject for undergrads with a year and a half of calculus, but not necessarily any more. In particular, one need not have had a linear algebra course or even a course in ordinary differential equations to understand the material. So I don't know if that is particularly true, but I guess because they said with 15 years of feedback, so I'm guessing they must have asked a multiple of students to actually do this book and actually see if they would understand partial differential equations with at least some knowledge of calculus 3, as well as no linear algebra or no differential equations. And the first chapter, the first section actually, is on ordinary differential equations. So I thought, why don't we just try that? Why don't we just put it to the tests? Because I've always wanted to learn partial differential equations, but I always felt like the hurdle was a little bit long and I felt like I would never get to it. So I just thought, why not just get into it? Anyway, so enough for me yammering. Let's just get into this, shall we? So I have the book in front of me. I have to clear some stuff from my table here, and I gotta get my trusty pen. So this time we're gonna be doing some math today. Gonna be doing some math. Alright, so basically I'm probably gonna just take notes because I haven't read this book yet, so we'll start the study timer and let's get into it. You guys can chat in the chat and I will get to those, but I will be taking notes, so I don't think it will be too much of a issue for me to actually reply back to what you guys are typing. I do have a little bit of experience with differential equations. Of course, I haven't practiced enough problems, so let me just go down here. Because I was working on some differential equations before, but I don't think I got all these problems right. So I think I'm going to I think I'm going to delete this because I don't think I really need this. I was just practicing differential equation problems. Let's just clear all that. Hey, Peak to Flow, how's it going? Distract math with other topics, questions as possible. Yeah. But how are you doing, Peak and Flow? What's the best part of your day so far? Just erase those. Okay, so let's just zoom in. Okay. I'll probably just write a summary, because there's a summary at the end of the section, so we know what our objectives are. So the cover first. First order separable ODEs. So that's the first thing we gotta go. And they kind of write what it looks like, so I'm not gonna write that yet. Some of these I do have experience with, but I won't say I have experience with all of them. So when I glanced over this book when I got it, and I was like, oh, okay, I know this, and I've seen that, so. Doing all right, no high points, all equally good. That's good. That's good to know. So homogeneous. I probably have to read that section. So, because I don't think I probably did cover that, but like I haven't looked at my differential equation notes in a long time, so I'm probably very rusty with that. Linear ODEs. And number 4, I think that's the last one, linear systems. So I think we got to cover both 3 and 4. Hey Cube, how's it going? What's the best part of your day so far? No, it's okay. It's just a typo. It's all good. But what's the best part of your day so far, Cube? Alright, so yeah, if you guys want to just like chill in the chat amongst yourselves, as well as like do something productive on your side that you need to get done, you're more than happy to do so. And don't worry about like bothering me or anything. You know, you just chat amongst yourselves, because we treat this as if we're like in let's treat this as if we're like in office hours, and we're just basically, it's like we're all doing our own individual research, and then we basically are kind of like having our minds bogged down by problems, and then basically like, it's like, I can't solve this problem. It's like, dude, what's up? What are you researching? And then we discuss what we're researching, and it's like, oh, okay, that sounds like a pickle. Hey, e to the 2i pi, how's it going? And actually, guys, if you're not familiar with E2's work, I hope you don't mind me shortening your name, making it easier for me to pronounce. Because I mean, I do love E to the 2i pi, but it's just such a mouthful. Is that just cool? Oh, okay. So I will give you a shout out. Let's see. Okay, I want to make sure. Actually, when I read your name, I was thinking of the anime Zatch Bell. Okay. Integrating factor, yeah, I'm familiar with that. Okay, here we go. Second order. Let me just check. Okay, so this is still okay. I want to make sure that when I see a box, it's not like there's like stuff I have to read before that. Oh, hey, Big Pup, how's it going? Today's objective is seeing if I can learn partial differential equations from a book I got. Because according to the book and according to the preface, it basically said you need like a year and a half experience in calculus and very little in linear algebra. It says like you don't even need linear algebra, and they teach you a little bit of teach you a little bit of differential equations at the first chapter. So I want to see if it actually lives up to the reputation. Because they said they actually did use this book for like 15 years, and according to students, it actually does work for them. So I'm like, yeah, why not? Let's put the textbook in a test drive. I don't know if we're gonna actually cover problems today, but well, when I say cover, I mean do problems. I don't know if we're gonna do problems today, but hopefully we can get at least 1 or 2 problems in. Let me just take the chat off, because like it's not keeping up with what you guys are typing. Okay, there we go. Alright. Oh, and forgive me guys if I read the textbook out loud. Just so that I don't, like, so the basically fills the silence sometimes. Let's see, we need a good understanding of homogeneous second order linear differential equations. I hope I don't mix up with the homogeneous part, because I know homogeneous has like 2 definitions within differential equations. But it looks like the homogeneous definition they're using here is 0. Like the whole equation is equal to 0. I mean, that's what it looks like. So it's a second order. So this is what it looks like. Yeah, I don't even remember, like, I know I've written notes about second order, but I barely remember what you do with second order. Hey, Penn Center, how's it going? Avatar is back. Yeah, if it gets too annoying, because, like, I'm looking down a lot, like, because I know when I look down, it shrinks, but if it gets too annoying, I will probably turn it off. So yeah, we're actually gonna do partial differential equation. Homogeneous, yeah, homogeneous is like, there's like 2 definitions of homogeneous in differential equations. I forgot the other definition. At least that's what I've heard. Because I think the word has been used like in 2 different ways in differential equations. I know one way is that the whole equation's equal to 0. That's one way of defining a homogeneous equation, but since we got a lot of math people in the chat, like maybe you guys can explain it better. Because it's been a long time. I'm thinking about Homo sapien cheese. No, it's not that. I don't mean that. And also, guys, if you're also into math, be sure to give Penn Center a follow. They also provide a lot of awesome math content, and him and Zach basically put up a linear algebra course. So if you guys want to learn linear algebra, you can definitely check out their channels while they're doing linear algebra content. So Zach basically posts like stuff about infinite series. PodCamp, yeah, PodCamp, yeah, nice. And also Penn Center's doing linear algebra in addition to real analysis. So yeah, if you guys want to actually keep up with their math content, like, be sure to give them a follow. And also, they've been awesome, like, people for me to chat with, especially when it comes to, like, math and stuff. So I know they know their stuff. And forgive me if I, like, sound like I'm doing something. I'm actually taking cough drops. And I actually have to stream again tonight. Like, on my other channel. Don't follow, it's a trap. They'll get you with linear algebra. The next thing you know, you be in a math cult. Oh my gosh, peak to flow. Let's see, where the coefficients A and B are real constants, okay? Oh. I gotta move over here. A and B and C are real constants. If A is equal to 0, then the equation is either linear first order ODE. If B is 0, trivial. Okay. If A is equal to 0, it's a linear linear first order. Well, yeah, based on the way it looks, yeah, that makes sense. ODE. So if B is 0, trivial. So I'm guessing it's trivial because it's a second order differential equation at that point. Hey Tyrion, how's it going? What's the best part of your day so far? Why try lead you the wrong way so that you can learn what not to do? Does your title need the words constant coefficients? Otherwise it becomes a nightmare. I don't know. Basically it just says real constants. Yeah, it says where the coefficients A, B, and C are real constants. Thus we assume that A is not equal to 0. The usual method of solving the equation is first assume that the solution is of the form e to the rx. Okay. So if A is not equal to 0, assume that a solution is of the form y of x equals e to the r of x for some constant r. Oh, my icon. So I guess I'll turn it off. Yeah, that's what I hate about it. It's like I would like to keep it on, but it just fidgets whenever I'm like writing something. You have up there second order ordinary differential equation with coefficients. Yeah. But thank you for letting me know that my icon was shrinking. Or my V2 bottle, actually. But what's the best part of your day so far, Tyrion? Okay, so we would have to rewrite this as A R squared B. Oh, interesting. Okay. And then factor that out. Kind of reminds me of substitution in a way. Interesting. Okay. Thus R must satisfy the quadratic equation known as the auxiliary equation. Okay. Oh, I think I've heard this term before. I've heard the auxiliary equation before. Maybe this is something that I have learned, but I just don't remember it right away. Dot dot dot. Let's see. Let D equal oops, forgot the A. I have to go back to it. You can just Next time you may wish to make your stream output variable. Let's see. The auxiliary equation is an algebraic equation where you solve for roots. Yeah. I mean, that's what it looks like because it reminds me of the quadratic formula. So R1 is equal to negative B like, is the music like sounding very off or something? Like, let me know if the sound quality doesn't sound right, guys. Like, whether it be like my voice or whether it be the music. Okay, so there's the three cases where D is greater than 0, where D is equal to 0, and where D is less than 0. Okay, so actually we should move this down a little bit. Okay, if D is greater than 0, yeah, then we have two distinct roots. In this case, the general solution. Oh, there's something that I forgot to erase. DM me on Gold server after I give you some screenshots. In this case, the general solution is a superposition. Superposition in your combination. So what is everyone up to today? You all just chilling? Working on something special? Researching? Studying? What are you guys up to on your side of the world? 1, 2. Aha, okay. Interesting. And C and 2 are, oops. Are arbitrary constants. Let's see, recall that the superposition of two solutions of a homogeneous linear equation is also a solution. And they reference like a problem that we can do to verify that, I think. Let's see, moreover, if the equation is second order and the ratio of two particular solutions is not constant, i.e. they are linearly independent, okay, then any solution is a superposition of these two solutions. I have to read that again. So recall that the superposition of two solutions of the homogeneous linear equation is also a solution, right? Moreover, if the equation is second order and the ratio of two particular solutions is not constant, hence linearly independent, then any solution is a superposition of these two solutions. So if d is equal to 0, then there is only one solution. R is equal to world domination. In ODEs, e to the rx is almost always the answer. World domination plans continuing. I'm thinking about continuing a story I'm writing. Oh, what story are you writing, Big Pup? You should write about Jeff is about to conquer the world. I'm stuck about understanding how to find the periodicity of a function in Shor's algorithm, but I will get it eventually. Hardest part is finding a clear explanation with an example. Which is a root of multiplicity multiplicity 2. However, recall that in addition to e to the rx, there must be another linearly independent solution to the equation. By trying a solution of the form f times e to the rx, one finds the derivative of f to equal 0. Thus, choosing f of x equal to x, we obtain another linearly independent solution, x e to the rx. Hence, when d is equal to 0, the general solution is, so it's it's a sci-fi story. It takes me a while to write because I'm trying to add real life physics into the story and make animals that would work while making them weird. Interesting. Maybe you and I should like actually like write out our stories and just read them to each other. Okay. So basically, you have to get, so R is basically going to be like the same for both of these. While like in the other one, R has to be 2 different types of R's. Sounds simple enough. R complex. I knew that was coming. Negative B plus I of D. And I feel like this is going to be very nifty. I'm always curious about complex variables. Honestly, this is not a bad that is not that bad of an idea. Hey Famish, how's it going? Okay. Yeah, where I is the square root of -1, right? So, oh, I think I went over this before. So R equal alpha plus I beta. My beta is not gonna look the best. It's gonna look like a B either way. And R of 2, R is equal to alpha minus I of beta, where and beta are real numbers. Okay, I think I have seen this before. I just haven't practiced a lot of problems with this. Hence, the solution should look like this. X plus 4. You think it would be entertaining to stream math without a mic? I mean, if people don't want to listen to what I'm saying, you're free to mute me if you like. I mean, if my voice is too distracting, you're free to mute me if you want. Where's C and C4 are arbitrary constants. Short answer, no. no. I'm new to this whole like math streaming thing. I don't have a mic, but I want to get into math streaming. Oh, okay. I see. I mean, it's honestly, if you want to teach math, it's better for you to have a mic, I think, because that way you can explain what you're doing, your thought process in real time. It's not about the subject, it's about the person combined with the subject. Yeah, exactly. I agree, Sensation. It is about that. Let's see where. satisfies the equation. In order to construct a more useful form of the solution, and we use Euler's formula. Oh, this is going to be fun. Euler's formula. What other stream are you doing tonight? I'm gonna be streaming on my other channel. Me and a college friend are gonna do our podcast there. It's not gonna be about math or anything. It's gonna be about anything that comes to our mind, whether it be anime or whether it be just like thoughts that we're having about, like, you know, society or something, or just like, you know, probably talking about our old age of being at 30 or being over the age of 30, you know. It's just deep talking, mainly. I mean, if you guys want to check it out, let me just... plug it in here for you guys. So if you guys want to check out my podcast tonight with my college friend, you can give my Uncle Talks channel a follow, so you can be up to date with that. That's actually my first channel, by the way. Okay, path integral time. I have been putting it on hold for 2 days. Nice, yeah. I have to like review the complex number part of the first chapter of that book. Let's see, Swift-born mathematician and physicist Leonard Euler made an important contribution to mathematics and celestial mechanics. The numbers setting z to... Oh, okay. Oops. Dun, dun, dun. Videos are overrated, and again, an issue. No mic. Oh, I guess someone must have like subscribed to my other channel, because I think I heard a sound alert for that channel. Because I'm like, that's not right. But whoever followed my other channel, thank you, I guess. I think I said like, but I really appreciate that, actually. I think it's because it's just like I'm on my math channel, so it's like kind of strange that I actually heard a little brief of the sound alert from my other channel on here. I think it's because I have one OBS on this. But all in all, I always appreciate you guys, wherever follows you drop. And if it's your first time tuning into the Math Spellbook channel, and you like math and you like physics, be sure to drop me a follow. I always post my VODs on YouTube, so like if I do something and it kind of like solved the problem that you were solving, but you just like didn't catch like the first part I said or something like that, or the first part I was writing, you know, you can go back to the you can go on my YouTube channel and basically catch the VOD there. I always upload my VODs on YouTube. Thanks, Big Pup. You can record with your phone and then just place the audio bit into YouTube. Yeah, that also works. And also, there's a editor called DaVinci Resolve. It's free, so you can download that and then basically just edit your videos. I personally don't like editing long videos, but I like editing short ones. So I could probably make an opening for like a show, but I wouldn't want to edit the whole entire show. Let's see, now using the relation of multiplied. So almost forgot the I there. That is equal to exponential rule beta. So then we can rewrite that as E times X cosine beta X plus I sine beta X plus 4C4 cosine beta X minus sine I sine beta X okay. Setting C1 equal to C3 plus and oop, that and is like really squiggly, and C2 equal to I C3 minus C4, therefore becoming Y is equal to, well, that looks really pretty. This book is actually pretty good because they actually boxed in all the important formulas in. I know like older math books don't do that. This one was printed, I think, in the 1990s, I think. Don't like that beta, though. Did I miss any I's? No. Okay. Let's see. Finally, with the notation... Okay. I'm 21. So the R's we obtain. Oh, we actually have to put in those two. So then we actually would obtain. You need the resolve to learn DaVinci Resolve. Yeah, that's also true. But there's plenty of YouTube videos that, like, I don't know everything about DaVinci Resolve, but I don't think it's as intimidating as everybody makes it out to be. Like, there's a lot of helpful videos that will teach you exactly how to use it. And plus, it's fun. It's, like, fun to actually learn editing software sometimes. Especially when you like learn things like the green screen trick and all that stuff. Well, I say trick, but the editing green screen videos, or like green screen like cuts, so you can put anything in the screen. Oh, cool. They even summarize everything I just wrote, like in one box. That's very nice. An object... Oh, so they give an example of it. Let's see. An object of a mass m is attached to a spring which lies along the x-axis as shown in figure 2 below. Yeah, so they show us a figure with the spring. Unfortunately, I can't show it to you guys. Yeah, because I was actually trying to find a PDF of this book, and unfortunately there isn't one, at least as far as I can find. So, I mean, like, I have the physical copy with me. Unfortunately, I don't have my document cam, so I cannot show you what I'm reading. And plus, I have a lot of stuff in, like, my Percinity, so I wouldn't be able to have enough room for my, document cam to, like, show you the book. Let's see, with Hooke's law, in effect, when an object is displaced... just turn the music a little bit down there. Let's see, with Hooke's law, when the object is displaced to position X, the spring exerts a force negative kx towards the origin, since the constant k is positive on the object. Let x of t be in the position of the object at time t. The object is due to air resistance, which is b. If the object is released from position x naught at time 0, time equals 0, find the position of the object at any time t is greater than 0, using Newton's second law of motion, which is m to the second derivative of xt equals ft, where ft is the total force on the object at time. And oh, that's just a little bit of a bracket. Okay. Interesting example. They actually showed us like a little bit of Hooke's law in here. So the second order differential equation, so second order linear differential equation. This would really help with that type of problem. Interesting. I'm probably going to say like interesting or intriguing a lot in this stream, because this is my first time I'm reading this book. Oh, they even go into a little bit of electronic circuits. That's pretty cool. And then they go into special systems of ordinary differential equations. Yeah, I kind of like this book because like not only does it kind of ease you into like showing you exactly like every topic, but it shows you examples, especially physics examples or engineering examples, which I really appreciate. Because I like math with applications, actually. I mean, it doesn't have to have applications, but I kind of like math that you can apply to like real-world systems. All right. I know I was just doing a lot of note-taking, but I just want to be able to absorb all the knowledge that was like in this book. But I actually really like this book, actually. I mean, obviously, it's not meant to make my life easier, but the way they explain it, it just feels right. And it's a big, chunky book, but at the same time, I know because of the thick and chunkiness of it, I would be able to read it and not have, like, problems. I mean, like, the thickness of the book basically shows me there's a lot of knowledge in here. But the way that the author wrote it, it feels very comprehensible to me. So I'm kind of thankful for that. So if you guys are working on anything, hopefully you're able to relax during our break times. But yeah, Big Pup, like, I would like to actually read your story. That sounds like it will probably, like, get me inspired to actually start writing mine. I actually have to, like, study a little bit about power series with my story, actually. Because, I do know what... I do recognize what a power series looks like. The thing of it is that I don't fully understand, like, I guess, like, problem solving with power series yet. As well as, I guess, like, how they apply within, like, I guess, physical laws. So I actually probably would have to go into, like, ChatGPT for that. I mean, what else is there? Yeah, because, like, I think I always wanted to learn partial differential equations, but I guess it's because I felt so behind. Because when I went back to school for engineering, I think I took, calculus, calculus 1, calculus 2. I took calculus 2 during the summer, which was a big mistake for me because, one, the class was rushed, so I didn't fully absorb the material I probably should have. Like, I mean, I did pass the test, but at the same time, I didn't fully absorb, like, all the information I could have gotten from that class. Which is unfortunate, so I would have to practice everything on my own for Calc 2. Not everything, but, like, a good majority of it. I mean, I'm surprised I still remember integration by parts. I mean, I did learn tabular on my own, and that's usually thanks to the Math Sorcerer's videos. I love the Math Sorcerer. I love watching his content. It's just so good. And his Udemy courses are pretty engaging too, actually. He gives you a lot of examples, which I really love and appreciate. If I didn't have those examples, I would be like, oh my goodness. And also, I think, like, what I like about his teaching style is that he will remind you what math that you've learned, like in Calc 2 or Calc 1, if you forgot. And I mostly appreciate teachers that do that, because there will be stuff that I forget from, like, previous courses. Like, when I saw the term multiplicity in the book that I'm reading right now, I was like, oh, that's from algebra. That's from algebra. I remember that term. And I think you learn that term when you're learning about polynomials. Or I think constructing graphs with polynomials. And I'm like, oh, multiplicity. I remember that. I haven't done problems with that in a long time. But I would have to say that, you know, like, math is hard, especially if your professor or teacher expects you to remember every single thing you've learned from the previous courses. And sometimes you have to know techniques that you probably didn't cover in those courses, and that makes it even harder. Because, like, I think, like, in high school, most students would complain. It's like, oh, they never taught us that. You never taught us this. But of course, in college, you can't really make that excuse, because obviously, like, they expect you to know this. And unfortunately, if you don't know it, you have to learn on your own. But learning on your own, I think that's, like, basically the best muscle to exercise, because it allows you to feel as if you're in control of your study habits and your learning strategy. And I think that's the most fun, because I think for me, it's like, I feel like there's, like, a lot of, like, fluff that you learn with each subject, and they teach it for specific reasons. But then, like, when you get to the next course, you realize there was only a little bit of the knowledge that you got from the previous course that you've learned. Like, I think that's why, like, for me, if I were to take, because I already have algebra and calculus 2, but I barely remember calculus 2. So for me, I would prefer taking differential equations after calculus 2, because it reinforces the calculus 2 that I have forgotten. So it basically gives me more of a motivator to study Calc 2 again, to practice those problems and actually put them into the differential equations that I'm actually learning. Versus if I were to do Calc 1, Calc 2, and Calc 3, and then differential equations and partial. But of course, everyone has a different way of getting around that. Like, I mean, having learning a strategy revolved around that, I think. I mean, some people prefer that typical route where it's like calculus 1, calculus 2, calculus 3, and then differential equations, and then partial differential equations. But I think any course that helps reinforce something that you've learned from the previous course, I think that's usually very beneficial. But at the same time, people can make the argument where it's like, but if you take differential equations before calculus 3, then you're not going to remember the stuff for differential equations for partial differential equations, which is reasonable to make. I mean, the thing of it is that if you're studying on your own, you could basically study Calc 3 and partial differential equations at the same time. I mean, obviously, there's going to be some hurdles. Like, basically, like, you have to remember all the stuff, and not only that, like, there will be some stuff from Calc 3 that you probably won't learn yet for partial differential equations, so you might have to put partial differential equations down for a couple days just to catch up with the stuff in Calc 3 that you don't have knowledge of yet. Because I think I was, like, talking to one of you guys before, and I think one of you were mentioning about, like, Stokes' theorem. And, like, I have no experience with Stokes' theorem. I've heard of it, but I have not fully, like, delved into the weeds of what it is. Like, I know it's like a more general version of Green's theorem, but I even forgot what Green's theorem was. Which shows that I don't have a lot of knowledge in Calc 3. Like, Calc 3, like, I remember, like, I know vectors because of physics and linear algebra. Like, basically, like, dot product and cross product and stuff. I still have to work on distances between, like, you know, the plane and between, like, I think a vector or something like that. Like, you know, the distance formulas for different scenarios within multivariable. That I have to actually, like, practice. I do know divergence, curl, gradient, and the Laplace, the Laplacian. All that I got from my my student's guide to vectors and tensors book. But the thing is that, like, I feel like I think multi integrals. I did watch a video about that, and the way they explained it. I don't know if you guys are familiar with Professor Dave's channel. Like, I think I don't know what his full channel name is. It's like Professor Dave Explains. I think that's what he calls his YouTube channel. I watched this video on multi integrals, and it was just so clear to me that I was like, wow, that's really cool. So, like, I basically learn things in pieces. I don't really go by unit sometimes, because if I get bored with a certain section, I end up, like, kind of, like, moving on to something else. I don't know if that's how you guys learn. Because for me, like, sometimes, like, if I was learning, like, Calc 2, and I ran into, like, a block where it felt boring, or it didn't felt, like, that entertaining, or I felt like I just didn't fully grasp it, I just basically put it down and move on to something else. Of course, like, math is not a spectator sport, so you still have to do problems. But I always find it interesting when I just read it, and it feels as if, like, I'm kind of just learning a piece of, like, extra knowledge. Now, of course, like, the thing of it is that, I think, like, with higher levels of math, I think it gets a little bit more interesting. Because, like, when you get into proofwriting, that's when you feel like you actually are able to, like, manipulate math as if it's some sort of game. Thing is that what do we have next in this book, actually? Because I think the next part is, I mean, other than the examples here, they say special system of ODEs. So, let's see. Occasionally, we will be in systems of linear ODEs of the form. So that's going to be interesting. Oh, and I think it just goes into the exercises then. I wonder if there's any notes I had about the section I just covered. Because I do have... I did, like, basically... like, on Udemy, I actually have the Math Sorcerer's, like, I think, like, differential equations course. I basically picked the one where he just lectures to his own classroom and records himself. So I actually took notes from that course, and, like, he gives really great notes. Like, he explains it so clearly that I'm like, wow. Like, he even covers the stuff that from Calc 2 that I don't remember, and I'm like, it's like, this is the class I need, because it's like awesome refreshers. Yeah, I think like DaVinci Resolve is like basically like I think it's like similar to like yeah, like Photoshop. Like you just basically add to the timeline and you just edit like, you know, the footage that you have there. Let's see. Oh, like I even have notes on linear nth order DEs. Homogeneous linear DEs. Yeah, I do have notes on the auxiliary equation. Huh. This is what happens when I put down a subject for a long amount of time. I'm actually glad I found these notes. So, yeah, because I basically decided to continue on with his differential equations course. I basically took notes on Laplacian, no, not Laplacian. Yeah, Laplace transforms, actually. And the Laplace transforms, I'm not gonna say they're easy because I haven't done problems with it, but the way they look like from the examples the math sorcerer gave, they seem pretty straightforward. The inverse transforms look like they're a bit challenging though, because you actually have to take apart problems and, I mean, take apart, like, I guess the expression and then just basically just manipulate it to like actually look like the transform that you're familiar with. I haven't finished like his video on the inverse transforms, because he gives a lot of examples in that. Like a ton of them. He actually covered partial fractions, which is something that I also have to practice on. But I'm pretty sure you guys are already like ahead of me when it comes to like actual like mathematical knowledge. Yeah, I think we're gonna do like one. I think we're gonna do one more study session, and then we'll probably conclude it for today's stream. Tomorrow we'll probably try to work out some problems. So before we continue on, I will be right back, guys. So just 1 second. Alright guys, I'm back. I won't put my model up, but I think we'll continue on. So now we're doing special ODEs, special systems of ODEs. So hopefully this one will be just as not, I don't want to say generous because that means I would have to get it right away and like spoon-fed. But hopefully the explanations about this section are just as fluent as like the last one. So let's start the study timer. There we go. And hopefully you guys are doing your own projects as well and are coming along with whatever it is that you guys are working on your own. Oh, I can turn on the eraser. Oh, so I have to hold it for the eraser. But can I switch between? No, I can switch to the eraser, but I can't switch to the pen from the eraser to the pen. That's unfortunate. But, you know, sometimes it's never perfect. Which is fine. Special systems of ODEs. Okay, occasionally we will meet a system of linear ODEs of the form the derivative of plus, should make this a t, make it obvious, and then b y of t, and then y prime of t, cx of t plus dy of t. Okay, where a, b, c, and d are real constants. Oops. Real constants. Yeah, and x and y of t are unknown functions. Okay, we are required to solve the system for the equation given the value okay, so the initial values of x is 0. So we have to set oops, so x of 0 and y at 0 initial values. Initial values. Okay, if b is 0, you can solve a first order differential equation. First order ODE for x, then substitute the solution x into okay, and then solve the resulting first order DE for y. If b is not equal to 0, we differentiate both sides as follows. Okay, so, and I'm guessing if a is like 0, then you do the same thing but with y of t. If b is equal to 0, solve the first order ODE. If b is not 0, differentiate both sides. So t, and then derive this, which is equal to xt plus cxt plus d plus c of t plus minus where we use the last inequality, thus must satisfy t plus equals 0. I'm just like trying to see how this puzzle piece works. Let's see. Differentiate that. Derivative of that. Excuse me, guys. Like that. See. Plus ED. Okay. This is a familiar second order differential equation is to solve for x. The initial values So it immediately jumps to an example here. So solve for dxt using the initial values. So the initial values because if you differentiate this, then you get this, and then because then b is over. Ideas suffice to solve certain other types of systems of ODEs which arise in the sequel, and there will be no need for differential operators and matrix methods. So now we go into examples here. Alright, so I think we can just work out some problems here. I think we'll shift this over here. Okay. Exercise 1.1. Find general solutions of the following separable equations. Actually, how many problems there are? So that we got 1, 2, 4, 5, 6, 7, 8, 9, 10, 15, 18, 20. So we got 20 problems. It's just that each problem has like multiple parts to it. Which is probably a lot of people are like, that's typical. It's like, you only have 20 problems. Yay! In multiple parts. Boo. But separable is not that bad. Oops. Forgot to write. Forgot to write this. Which leaves us with doing that. I mean, with the absolute values, I mean, is there a way to get rid of them without having to like make a negative and make a negative and a positive version of this? Because I know when you basically bring up the natural log into E, it should cancel it out. The thing of it is that I don't think doing that cancels out the absolute value symbols, does it? Or it does. I don't think it does, right? Yeah, because I know like when you do the integration, you always have to put it in the absolute value. I just don't want to write like negative c e to the x squared over 2, like a negative version of it. Unless we can just consider it just y, because then again, like y is like still like because it would be positive either way. Because because technically the absolute value is like a distance. Actually, are there solutions in this book? I didn't even check that. Selected answers, okay. So it doesn't have all the answers, but have selected answers. I try not to look at the back that much. But at least it has some solutions. That sign. Okay. That doesn't feel right. Do you have to do partial fractions with this? I feel like we might have to. I think we can just leave it at B, right? Yeah, because it's not like squared or anything. And then we leave it at 1, multiply that, and right, yeah. So then we distribute the A. So then A plus B equals 0, while, well, actually it's supposed to be minus A. So minus A plus B. Then we have just regular A with 1, so A is equal to 1, which means B is equal to 1. Because we have a little negative sign there, so that makes it 0. So we have to integrate over x plus over 1. This one will be negative x plus, Well, actually, I think that would be negative because we have to. And that will be equal to t plus c. And I don't think we're gonna solve for x on that one. I think that would be too complicated. I mean, at least I remember that with partial fractions. I mean, hopefully it's right. If I am totally wrong, you guys will let me know, right? Okay, we got... Oh, this one's a bit of a interesting one. I mean, we could do grouping here. I mean, over here, but I don't know about over there though. So if we factor that out, 1, and if we factor out -1 plus, oh, okay, there we go. That's better. That's better. That looks nicer. Now we just have to separate these. I'm now back with an additional omelet. Nice, nice. Oh yeah, because what time? It would be like near lunchtime for you, right, Pen? Or is it brunch? Are you getting brunch? Yeah, 12:30. It's breakfast. Oh, okay. As long as you get those food groups in, it's all good. Actually, Pen, I have a question for you. This is, I think, the typical algebra question, I guess, because obviously, like with algebra, I barely remember the mistakes I made. So when you do e to the natural log of an absolute value, do the absolute values like disappear, or do you have to get rid of them? Like once you've done all that? Because obviously, like with e to the natural log, I know it goes to 1, and you basically just move the thing that's in the log outside. Like, do you have to do a procedure to get rid of the absolute value around it, or is it like kind of take it for granted that it will be that number? Because a part of me was like, no, the absolute values don't disappear. Because I feel like I should know this. I'm not entirely sure off the top of my head. Oh, okay. I thought it was like kind of an obvious thing. I felt like you guys probably should know it. That's the thing I don't like about the absolute values. I think you're right. You get... yeah, because in the absolute value, it's going to be positive anyway. So, like, I feel like they just disappear. Okay. Alright, so this integral is not going to be a problem. This one... Well, the left side is going to be a little bit of an issue. But the right side, I don't think it's going to be that much of an issue. Because we just do this minus 1 dx, thus giving us 3 minus x plus c. Ooh. This one, I think it's one of the trig ones. I feel like it's one of the trigs, but I don't know if it's for the arch or if it's for the or if it's for regular tangent. Unless I'm thinking of the wrong thing. So I think it ends up being okay since c is any constant, so multiply it, it's still 1 is a constant. Right. Dang, like this is like with Calc 2, this is where I was like struggling, because like I had to memorize these for tests, but because I memorized them, I didn't like actually like try to like convince myself like or develop a better study method to actually memorize them, like for long-term memory. Because I know with tangent, but I don't know if it's arctangent or tangent for this integral, because it's y squared plus 1, and I know with like I think if it's that type of integral, it's going to be either tangent or arctangent, but I don't remember. I think it's tangent, because it's supposed to be tangent of y, I think. And if like 1 turns out to be something else, it will be added to like I think the y term. I believe it's tangent, like tangent of y. I think I think so. I think so. I don't know. And I think you just take the arctan of the other side. I'll check if I'm right, like on using Google. Where's my mouse? There it is. Wait, I think the integral is arctan. The derivative of tan is... Oh, yeah, right. Yeah, I knew it was going to be one of those. Because I remember there are functions that, like, there are trigonomic functions that uses fractions. So you're probably right. Yeah, it is arctan. So would it be arctan of y, I think? Yeah, I think so. Thanks, Jeff. So then it's just going to be the tangent of... Yeah, those I always forget, because when I was learning Calc 1, we never covered the arcs of the derivatives of the arcs, or the like I actually had to learn the I think the integrals of like the arc trigonomic functions, but I did not know their derivatives. I actually always forget their derivatives of the arc functions, of the arc trig functions, I should say. But thank you for the reassurance, Jeff. Appreciate it. Oh, that's nuts. I covered arctan the most since it comes up so much. Really? Oh, okay. Yeah, because I know the arc trigonomic functions, or the arc integrals, they involve like fractions. And I think like for sine, it's like 1 minus whatever it is that's in there. Like 1 minus x or x squared or something like that. And I always forget the secant one. The secant one is like 1 over, and I think it's supposed to be like whatever constant like is in front of the x or something like that. And then it's supposed to be like, I think like that. I think it's supposed to be whether it be x, like x squared minus the constant like squared or something like that. I'm trying to remember. You need arctan integration to be able to do partial fractions decomposition a lot. Yeah, that's why I have to practice those. I think with partial fraction decomposition, like I feel like I know some of it, like basically the basic one, because like I did manage to do this decomposition here. But of course there were no squares in it, so that made it a little bit easier for me. I mean, if this looks wrong, like, let me know if it's wrong. Because I think you're supposed to do U substitution in here. And then you basically make it like U, and then you basically just put everything in black in its place. I'm not even going to try to solve for X for this, because that looks like a mess. Yeah, with Calc 2, I think all of the trig substitution I forgot. What else is there? Oh, wow. Like, my screen just doesn't want to cooperate with me today. Alright, let's go to the next one. Yeah, so we gotta do this one next. D. dy dx. Oh, what fun. Yeah, what fun indeed. Yeah, because like usually for me I would just like multiply on this side and then I would put this on this side and then I would divide this. I think of it in my head and I'm basically like, yeah, I would do it that way. So both of these are going to be like arctan. Arctan of x plus c, and then arctan of y. That means y is equal to the tangent of all this nonsense. At least like when I'm streaming it with you guys, I will remember it much better because I'll be like, hey, I remember this. This is when Penn Center said you do this a lot with partial fractions decomposition. I'll probably remember it better now, so because I'm not studying for a test, and plus I'm with you guys. I think that's right. Yeah, because like, yeah, I'm not gonna even bother like doing whatever doohickeys in here. dxdt plus. At least we're doing some problems now. I thought we were not gonna do problems, but we're doing like problems that I'm probably like easing my way into, because I do know about separable differential equations. I think they're the most fun because it just seems like they're just, I guess it's just like easy, I guess. But I know they're gonna get harder later on. So we have, I think we're supposed to solve this using the integration factor, or what do they call it? The integration, oh yeah, it is called the integration factor, okay. So yeah, it's in its general form. We don't have to change it or anything. So the x we have is... Oh, this should be fun. Real fun. And I'm not putting sarcasm into that because I kind of feel like I've done this before. Okay, so it's that, and I just want to double check just to make sure. And I don't think we have to put a constant there. Yeah, I don't think we have to put a constant there. So you multiply that plus square wait a minute. I think I'm doing something wrong here. Because it's sine of t. Wait. I think I have to hold the door here for a second. That's what it says in the problem, right? Yeah, to dx to t. So it's usually dy just Oh, I think we're gonna have to do it the other way because it's I got the variables mixed up. So it's not that one, it's this one. I think that's what we have to do. But wait, the one thing is that because if we replace this as y, x squared, so now I actually got to look back because like I think I'm getting my variables mixed up here. Integration factor. But this is good because it allows me to review what I think I know. Let's see, p x y was oh, whoops, it's supposed to be t. So the one issue is that this is an x squared instead of just x. That's the one thing that bothers me. But then again, does it even matter? X squared sine of t because would that be because it's supposed to turn out to be the product rule, and it's supposed to be the product rule of x squared, the derivative of, yeah, and then that'll be the derivative of x, and then this would basically, and you take this out, Okay, that's really funny. No, I don't think it should be like that. Yeah, this doesn't look right. What am I missing here? Do I have to manipulate this? Or do I have to actually separate it? I might have to separate it. Yeah, I think well, it's supposed to be a separable equation. Yeah, I think I have to separate it. I think that makes it much easier. I was thinking of it like I have to do the integrating factor with it. I mean, it looks like I can, but at the same time, it just seems much of a headache. So... yeah, I'm probably like making it too difficult than the way it is. Because it actually looks easier when I do this. I think I was like tricking myself with that, that's why. Okay, so this one, if you integrate negative cosine of t plus c, and then with this one, we'll just change it a little bit to make it look nicer. Or make it look more like it makes sense, makes better sense. So we'll just move that, and we'll put that in here. And then plus c. And then... I always forget this, so I have to remember it, so... because whenever I do like negatives in the integral, I always end up messing it up. So... I might as well just do it by hand. So we are left with, so the negatives will cross out, so it'll be x, yeah, it'll be like that, cosine of t plus c, and we'll just flip it over. And I think that's it, yeah. Yeah, because it looks like I could do it a different way, like the equation. I mean, probably I could, but at the same time, it just looks like it's more trouble than it's worth. Because I thought I had to do something else, but then with this x squared there, it made me think about it a little bit. And I was like, wait, that might not be right. My thought process might be wrong on that. Minus... then equals 0. So and y and x, and then you do this, x over here, y is over here. And then we integrate both sides. So we are left with x to the square plus, well actually I don't think it'll be plus. It'll be negative. So negative x plus c. Okay, so for this one, well, I guess we'll probably have to get back to that problem tomorrow. But I think that was pretty good. We actually got some notes down and we got into doing some problems, so yeah, I'm actually liking this book. So if you guys want to know the title of the book, it's Basic Differential Equations by David Bleecker and George, I think, Sordias. I'll type it in the chat so you guys can like find it if you guys want to like check it out. It's pretty expensive, I will say that for sure, but I think this is a pretty good book, at least for me. Differential Equations by David Parker and George. So if you guys want to check out that book, they have like it on Amazon, but there's like 2 versions. There's one that's like $400, and there's the one I bought, which is like around like hundreds, like, well, around like 92 somewhere. I don't know if they still have that copy. But yeah, I think this book is gonna probably gonna inspire me to get more into it, because like I love books that basically kind of like take away the fluff of the stuff that they think that you should know, and they kind of remind you what you should know in some ways. So I think this book is probably going to be something that I'm going to look forward to doing. But of course, I'll be able to be excited to do more problems with you guys. We'll probably like finish letter F like next time. Okay, so thank you for joining me on today's stream, guys. So if you guys weren't able to see the whole entire stream, you can check out my YouTube channel. Basically, give me a subscribe on the YouTube channel, so that way, if you want to check out my VODs and see what you missed, you can check out that. Because I always upload my VODs on YouTube. In addition, if you want to join our Discord server, the Math Spellbook Discord server, you're more than happy to do so. We can basically chill there, study together, as well as like probably ask questions to one another. Hopefully we can get some input from each other to get better at whether it be math or whether it be things that we're very passionate about doing. And also, if you want to check out my other channel where I play games and just chat with you guys there, you can check out my Uncle Talks channel. That's my original like Twitch channel, so hopefully you guys, if you up for playing games or like just watching me like fail at playing games, you can check out my gaming channel as well. And if you're tuning into the channel for the first time, you know, drop me a follow. It really helps me with the channel, and if you love math and physics, like hopefully I will help inspire you to get further ahead in your, I guess, academic or possibly like research journey, whatever it is that you're doing. And yeah, I think that will be it for today. So I'll see you guys tomorrow, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care, guys. Bye-bye.